right, so we're going to go through these wave speed equations in our notes today. We're going to open up the digital copy. And so we'll have that ready to go. I'm going to bring out our notebook. Let's go ahead and title our notes today, Waves 3, Velocity of a Wave Formula. What does the word velocity mean? It's kind of like speed, huh? I can't hardly hear you. It's kind of like speed. Velocity has a direction, though. Let's go ahead and write the formula. We have the formula here in our Canvas page. We'll go ahead and write that formula in our notes, and then we'll take some notes about the formula itself. V equals frequency times that thing. Well, yesterday we talked about how that thing is called lambda. So what does that stand for? That upside down Y. Right here, you can see it stands for wavelength. So we're going to go ahead and label these things so when we're doing the problems, we know what we're talking about. Wavelength, this is called lambda. If one of you guys want to turn the light out, that's fine. This is called lambda. And it's a Greek letter. A lot of times they use Greek letters in formulas, like standard formulas, so that we can have a symbol for it. What do we measure wavelength in? It kind of shows you in that picture right there, but it's going to be in meters because wavelength is a distance. Okay. Wavelength is a distance. So this is, you guys, this is a Mr. Obvious moment, but when I have the F and the lambda right next to each other, what operation goes in the middle right there? What are we doing mathematically? We're multiplying, right? So we could add the little multiply circle there. The F, so we're going to multiply frequency times wavelength to get velocity. So this F is frequency. Frequency is how many times the wave passes a certain point in a number of seconds. Frequency is measured in hertz. It doesn't hertz. No, just kidding. That's lame. Hertz is per second. So when we do math with it, we can write hertz, but we can also say per second. So we would have a number per second, like miles per hour. It would be waves per second, and that's what frequency is. And then the V. What does this V in this formula stand for? Velocity or speed, right? And looking at what we have here, wavelength is measured in meters, frequency is measured in per second. What unit is velocity going to be in? We know it's speed, so it's got to be a distance divided by a time. Meters per second, right? Now, the reason I want to make it really clear on the units that you're going to use is because if you start out with a velocity, you can use those units in order to make sure and check your work and make sure you have the right answer. So let's go to that practice page and we'll do some work together. Okay. All right, so I'm going to pull in that practice page from step 2 and we'll look at it just for a little bit and then we'll work through it. This page is kind of the same thing that we've already talked about. It gives you the formula, so you'll have another reference for it. It gives you the symbols, the terms, the units, and the symbols. Be careful of frequency. They expect you to already know that hertz is per second. So we'll talk about that as we do the problems. But let's look at the sample problem that's given here and kind of digest how they're giving you this example, and then we'll do some work together. So here's the first problem. A wave has a frequency of 50 hertz and a wavelength of 10 meters. What is the speed of the wave? Well, it's really easy to kind of get caught up in all the words when you have a word problem. But they did a really good job here of writing out the symbols that they're going to use in the formula. We know we're going to do this velocity formula. Velocity equals wavelength times frequency. So they write them all down. Frequency was 50 hertz. Where did they get that in the problem? A wave has a frequency of 50 hertz and a wavelength of 10 meters. And then what is the speed? That's what we're asked. So we don't know that. Then we just plug in the numbers and we come up with the answer. Give me a thumbs up if that sounds pretty straightforward and you feel like you can get it. Okay. All right, so let's do some problems together. We'll scroll down. These other sample problems just give you another example to look at. But I do expect that you're putting these in your notebook as examples for you to use later. I do not expect you to sit there and just blindly stare at the screen. I expect you to put these in your notebook. So let's look. Number 1 says, a wave with a frequency of 14 hertz has a wavelength of 3 meters. At what speed will this wave travel? Well, that's a lot. But we know we're going to use this formula that we just talked about. So let's go ahead and write it over here. So velocity equals frequency times wavelength. All right, I know I'm going to be looking for a velocity, a frequency, and a wavelength. I go back to my question. A wave with a frequency of 14 hertz. Okay, so I'm going to write 14 hertz. Now, they expect you to know that hertz is per second. So we're going to go ahead and write that 14 per second. So it's like a fraction. Whenever we say per, that's where the fraction bar goes. Back to our problem because we haven't got our formula plugged in yet. A wave with a frequency of 14 hertz has a wavelength of 3 meters. So which one's wavelength? Lambda. Lambda is wavelength. So we're going to put 3 meters there. What is the speed? My question is the speed there. So then I'm just going to plug it in. I still don't know what velocity is. My frequency, you could write hertz, but this one's going to make it way easier for you if you write 14 per second. 14 per second times 3 meters. Now you can probably do that math in your head, but I'm going to pull up my calculator and show you exactly what you're going to be typing in. You go 14 times 3 because when we multiply, we go straight across the top. That's going to give us 42m. Then if we go straight across the bottom, that's where we get our per second. So 42 meters per second would be our answer. Give me a thumbs up if that's easy. You feel like you got it. Okay, I see some thumbs. All right, let's do another one. Let's go ahead and do number 2, just for good measure. Now I know that we're already going to use this formula, so I'm just going to write down the formula. I'm going to write down my symbols, my variables that I am looking for, and then I'm going to read the question. The speed of a wave is 65 meters per second. If the wavelength of the wave is 0.8 meters, what is the frequency of the wave? There's a lot of words and numbers. So first, go back to the beginning. The speed of the wave is 65 meters per second. Where am I going to put 65 meters per second? By the V, right? Then you continue. So we know we've used this number. We can highlight it because we used it. if the wavelength of the wave is 0.8 meters, well, it tells you wavelength is 0.8 meters. What is that symbol called for wavelength? Lambda. So we're going to highlight the number because we already used that one. Then we have frequency left. What is the frequency? So we know that is what our question is asking. What is the frequency? So I'm going to plug it in. Times. Okay, so what do I need to do to get frequency by itself, to find what the frequency is? We know when we're doing algebra problems, we have to do the opposite operation. So if I am multiplying by the 0.08, then I need to divide. So I'm going to divide by 0.08. That will cancel. I have to do the same thing on both sides. Okay, so you guys might be able to do that in your head. I can't do that in my head. So I'm going to pull out my calculator again, and I'm going to say, all right, 65 divided by 0.8 equals 81.25. All right. So my calculator answer is 81.25. What unit is frequency? Multiply it. Well, let's go back to why did we divide? In our problem, we had the V, we did not have frequency, and we had lambda. We are multiplying frequency times lambda, frequency times wavelength, to get velocity. So right here, if I am multiplying to get rid of the number that's next to my variable, I have to divide. I have to do the opposite operation. So I'm going to divide 0.8 meters by 0.8 meters, and that cancels it out. If I multiplied it, I would get it squared, and the F would still have a number next to it. So I got to cancel. I got to try to get rid of it. So then here I have to do the same thing on both sides. If I don't do the same thing, it doesn't equal. And we said it equals. So we have to divide. Did I type in multiply though? Nope. So 65 divided by 0.8 is 81.25. Now what unit am I going to have here for frequency? Yeah, it would be Hz. It's hertz, but mathematically we're going to have per second. So that would be that's the same thing, okay? Because this meters is going to cancel that meters. And we're left with per second. So that is absolutely the calculator answer. But when you get into your CK12 and when you get into some higher level math, they're going to say, use the significant figures. It come back to haunt us, didn't it? If we look at our problem, we have two significant figures here, and we have one significant figure here. So the best, most perfect answer would only have one significant figure because we're multiplying and dividing. So when we look at our problem, we would round it off to 80 per second or 80 hertz. Now, I am going to count this right. Either one, 81.25, 81, 80, because if you have shown me that you know where to put the numbers in the formula and what to do with the formula, and you get to this point, that's what I'm really interested in, okay? But when you get into CK12, I don't want you to be confused or frustrated when it says use this number of significant digits. It's still going to tell you that, okay? It's going to require you to do that. So give me a thumbs up if that makes sense and you kind of get it, and a thumbs down if you're like, nope, still lost. Mostly thumbs ups. Okay. So essentially, this formula and using a formula is what today is all about. All right, I want to scroll down in the worksheet, and I want to look at number 10, because number 10, somebody said earlier, number 10 looks big and scary. Kinda, but let's go ahead and do number 10 together. It's just like any other classic word problem. Okay, they are going to give you a bunch of extra work. All right, so like we were saying, this problem has a bunch of extra stuff in it that you don't actually need to solve the problem. Okay, so we'll do 10 as an example. Radio waves travel at a speed of 300 million meters per second. That's a huge number. WFNX broadcasts radio waves at frequency of 101,700,000 hertz. What is the wavelength of WFNX's radio waves? Okay, you might have just stopped thinking right there, but go back to what we've done. We have a formula. This is what we're practicing, right? We need to find these variables. Okay, so radio waves travel at a speed. There's a number there. Which one of these is speed? The V for velocity, so that's where we're going to put our 300 million meters per second. I ran into my formula space. Now, we don't really care about the radio station. We care about these three variables right here. Frequency is 101,700,000 per second, because hertz is per second. And the wavelength, it says what is the wavelength, so we know that's our question. So we're going to go ahead and plug it right in. I'm going to use the space down here so I can write neatly. So just like we did in the problem up here, we are multiplying times our variable, and we want to get our variable by itself. So we're going to have to divide by that number to get rid of it. We're going to cancel it out. When we divide by the number, that throws our seconds to the top, so they can cancel as well. Okay, so our number cancels. Have to do the same thing on both sides in order to keep it an equation. Throw that S up there so they cancel. All right, so then, like I said, you all probably can do these in your head, but I'm going to put it into my calculator to make sure that I get the right answer. 300 million divided by, okay, got my numbers right, equals, okay, 2.94. I don't want to write all those digits, but I'm going to write a good chunk of them to make sure that we have a good understanding of what we're supposed to do. So the answer would be 2.94985. And I'll stop at 2 because this 5 right here would tell that 5, well, I should stop at 3 right there. That 5 would tell the 2 to go up. So meters equals lambda. Now, what would my answer be if I told you you had to use correct significant digits? You got to go back to our problem. In our problem, this velocity has one significant digit. Our frequency we're given has 1, 2, 3, 4 significant digits. So we have to go with the least number of significant digits, and that would put our answer at 3 meters equals lambda. So I will count either one of these right, but you need to understand that when it says significant digits, you have to go back and count them and use the correct rules. And we were multiplying and dividing there. All right, so I want for you to do the rest of the problems on that page. So we did one together and we did 2 together, and we did 10 together. So that means you need to do 3 through 9 on your own, and then take a picture of it and submit it, or if you're using DocHub or Kami, submit it that way through a PDF, right? Those of you